Hey guys, my name is Atik Mewada and I'm the founder of Smowcode. In this video, we will learn how general concepts of embedded systems work and how they affect your coding in Smowcode. As in the relation between the libraries that you'll be using in Smowcode with their natural concepts on how they have been created and why they were designed the way they were. We have a list of items that we'll be talking about, and we'll begin with the CPU frequency. So in Smowcode, you can go ahead and change the CPU frequency. Now, what is that? The microcontroller runs at a certain speed, which is defined by the number of megahertz that the CPU is running at. And what you can do here is select the megahertz at which the CPU should be working. And you can also select the maximum and minimum frequency. This is directly coming from an ESP library for changing the CPU frequency. There are other controls as well for changing the CPU frequency. Plus, there are a few CPU, there are a few system functions apart from changing the frequency that you can use. For example, system sleep. Just in case you want to save your power, you can put your system to sleep, and whenever this node is called, the system will go to sleep, and the type of sleep you can select based on the type of sleep um, the controller will either go on light sleep or deep sleep. The definitions of the same are available in the ESP32's datasheet, and maybe in a separate video when it will be out regarding the system nodes, you'll be able to see that. Um, Meanwhile, as we are speaking, we are increasing the documentation in Smowcode, which will go on increasing the way you'll be learning while you are coding as well. Now, when you put your microcontroller to sleep using this node, what will happen is it will go to sleep, but you'll have to tell when to wake up. It's like putting an alarm clock. So you can either put a timer after which it should wake up, in which case you have to specify the number of milliseconds after which the microcontroller should wake up, or you can tell if there's a signal change on a pin, in which case you can specify the pin or the GPIO level and the GPIO level. Then whether upon a UART RX event, or let's say some external event, or there are multiple options over here by which you can select how and when the system should come back from sleep. So that's about the CPU functions. You can, by the way, also keep tracking your memory. So how much memory has been used dynamically at each point of time, you can keep checking by calling this node, and it can tell you how much free memory is remaining. If upon each loop iteration, or let's say every 10 seconds, your memory is going down and down and down, that means you've created an unstable system. Now that is not usually possible in Smowcode until you have used your own C language code on the side. Just in case you have, there is a function for you now to check your dynamic memory that has been pending. Let's learn a little about arrays in Smowcode. Uh, the general concept of array is that you can create uh, similar kind of uh, data points in in the same in one block of location. So it's not like on address 100 the first element is stored, or the second element is in place number 200. No, they'll be right next to each other, 100, like that way in the memory. And based on the size, they might be having multiple bytes per element. And just if you want to store multiple data points, which an array calls an element, you can do that on Smowcode. That is also one more thing, one of the concepts that are there in C language, which you have learned already, how arrays work from zeroth element to the next. You can access arrays just the way you want. You can access it. Let's say you have an array, you want to make an array, let's say named array. You can make it by uh, creating an array like this inside square brackets, where all of its elements should be um, in the a comma separated inside the brackets, and you can tell which array type it is. Is it an array of uint8? whether each element is 8 bits, 16 bits, 32 bits, 64 bits, or each element is a float, or maybe each element is a text, in which case you can go ahead and write in double inverted commas 1, and like that way 2, 3 as well. And that's something about arrays in Smowcode, and in general the concept of arrays remains the same, just as well in Smowcode as well. There's one more thing about Smowcode's arrays. The concept of arrays in Smowcode is a little extended as well. So let's say we go to the array nodes. You can insert elements in the array dynamically, as in you don't just get to create an array of a certain size at the start, you also get to change its size by, let's say, you can add more and more elements into the array by telling the array name, uh, whichever the variable name is for the array, and on which index you want to add another value, or let's say a new element, and that's how you can do even more. Sorry, we had a cut in the video. So we were talking about arrays. We have a lot of other functions as well, like array append, which will append any new element to the array at the end of the array. There's array pop. You can remove any element out of the array from the highermost side. You can also do array get size. You can get the size of the array anytime uh, during your program. Dynamic length is something that you'll get. In Smowcode, we use a concept similar like Python's to create, resize your arrays in the most efficient way that we can. Um, then we have, so we've done CPU frequency arrays. Now let's understand a little about buffers. So I usually open my notepad screen to talk about text-based work, or let's say concepts. So there's something known as buffer. A buffer is an array of 8-bit element size. This is the clear definition of buffer. So array uint 8 is equal to array is equal to buffer. Whenever you see buffer name, you have to understand that it can accept a uint8 array. Okay, which is equal to something like this: 0, comma 2, comma 5, up to 255 is what you can put in the value of a buffer. Array int 8 is also totally, you can give it to a buffer, and that will also be handled, that will be taken as a buffer. So let's say the value will be minus 128. In case of int 8, that will be considered as 255 in buffer, and that is something. So this is how two's complement type integers uh, integers work. You can check it's how that works. It's simple. So 0 till 255 is, let's say, positive numbers in case of uint series. Then you can say 0 to 128 is positive, 127 is positive, and then when you go minus, so how it happens is, so just like a normal number series, 255 is the last for an 8-bit element, for an 8-bit memory size. What will happen is 255 will be the highest value. If you go ahead and increment it further, it will become 0. But if you decrement 0, you'll come to 255, and you will, so 128 to 255 is nothing but int 8, int 8's series. Now here 128 means minus 127, and 255 means minus 1, and 0 means 0, 127 means 127. So whenever we write minus 1, sorry, here I was wrong, it is minus 1. So whenever minus 1 is written, you can assume it's going to become 255 whenever it's converted to buffer. Now that's about arrays and buffers. Okay, buffer is nothing but uint8 sized what we say element size. Now the thing with buffer is, and always buffers require you to tell the length or store the length on the side. Now this storing of length for every buffer, or let's say an array unit 8, is done automatically on Smowcode internally, automatically and internally in Smowcode. That's how Smowcode automatically handles quite a lot of features for you directly. Uh, you just need to do get size at times if in case you are working with arrays or buffers, and you'll get the size of the array or buffer that you're working with. Now let's say, now there's one more concept that's a little similar, which is text. Now text we usually write like this: A, B, C, D, E, F. Now what happens is we have taken six characters, but no, we have to take one more character for the null pointer, for the termination. Okay, that's called the termination character, which is usually a null. Now in your data, if your data contains can may contain null, which is not the case in null means zero. The value is zero in 0 to 255 in a 8-bit uh, memory. Okay, so let's say your data contains null or may contain null, then you should go for a buffer or an array unit. They both are exactly same. They're synonymous. Okay, and it doesn't, if it won't ever, that means you can go for text. Then you can go for text. That's what. This is a concept that you should understand for you to be able to use Smowcode better. For example, in a display node in Smowcode, it will take text. So it will say that it's taking text on the left. If you see the data type written in the tooltip at the end in the brackets is text. That means this expects that you don't give any null pointer to it in between, and you can write a b c d e f g. Okay, and it will, if a null pointer is given in between, then your string will be limited to ABC only. Although the memory stores ABCD, then a null, then DEFG. By the way, this is called an escape character. For null, we cannot write a zero, else zero will be printed. So slash zero is how you write a null in Smowcode. Let's say you want to write just a slash, that cannot be possible. You have to write double slash. Okay, uh, so that is something about the escape character's first character. Usually it cannot, if you want to genuinely use that character, you'll have to do it double times for you to be able to use it. All strings in Smowcode do support escape characters. um, so here it's taking text, but if you go to UART node, so there's serial write. Now, if you take the serial write node, it will accept buffer. If you see on the left in the tooltip in the brackets, buffer. That means you can give your an array which can have a null in between as well. You can do that. Why? Because it accepts a buffer, and buffer has a size. So the size of this buffer has been determined now automatically by Smowcode as 4. It will send the 4 bytes. It will not stop at the 0. So that's about text and buffer. And because it was buffer type, you can always give text to it. So if you type your hello, it will take it as a 6 element long array automatically. To a buffer, you should be able to give an array, text, as well as a uint8 array. You can do whatever you want here. But to a text, we prefer you only give text. If you give an array and you somehow end up adding a null inside it, then the entire string will be stopped there, because string is measured from the first character till the termination character is uh, encountered. So this marks our end of the buffer and text series. Here we will now learn trigonometric and string functions. So just like y is equal to sine of x, if this is what we want to do, if we for any x value we want the y value, then what we can do is we can apply a trigonometric function here. There's apply trigonometric, there's a hyperbolic, there's logarithmic, there's, so there are many of the functions that are available here from the math.h of C language. Floor functions here. So how to use them is very simple. You just tell it. So let's say you have a node here. Let's say that creates a value. Let's say 90. X equals to 90, and you want to find the square root of, let's say, 90. Then the square root answer will be here. Wait, sorry, x's value, which might be changing as well as per your program. Then you'll get the answer as here and square root number, which you can print as well, like this. Square root of x is I just forgot the name of the, yeah, sqrt number, whatever the variable name that was set here. Now we were talking about trigonometry. I just got lost in the, by mistake I took the square root node. So we can go ahead with apply trigonometric functions. The name is something that we'll be fixing. It's we are currently having one of our team members working on a lot of user experiences. Might be that the S was a typo. So yeah, X, and you'll get the output in Y, and bingo, you can go ahead and print the value as well. The sign of X is Y. This is something that you can do in Smowcode. So this is how probably the whatever the C language units are for the sine x, whether it's degree or radians. Smowcode as well uses the same. If we quickly find it out, trigonometry functions in C. So all of these are in, we call it pi equals 1. So as arguments and return this one. Yeah, so what they're currently doing is, yes, it's in radians. So in Smowcode as well, you have to type it in radians. So my tech team currently is working on these items, and they know more about this. But I know for a fact that they've used C language functions, so you can directly expect C language being used here, C language units being used here. As we are updating our document, so you'll find in the document itself that trigonometric functions use which degrees or radians, which unit are mentioned here. So now we'll move ahead with the string functions. So there are even string functions here in the utils category, which is just below the loops category. We have a lot of utility nodes, including the string nodes. You can do string comparison, whether or not two strings are equal or not, string search. So the thing with strings is that string is an array of characters with null only at the end. But this is not the main point. The main point is string is an array of characters. So you cannot write str1 is equal to str2 in Smowcode. No, you'll have to do a string compare. We'll soon be adding a smart way as well, in which if anyone ever writes this, this will also be internally taken as string compare. But this is something that as of right now you should be doing via string compare node separately. So do ensure that you're using that. String functions are separate always. String search, string compare, and there might be more as well. So that is about the string nodes. So this marks the end of these functions, and there's one last function that we'll be working on. And over here we have a lot of data to be given here. Now this node is a very beautiful node. What it can do for you is it can convert a value from an x1 x2 range to a y1 y2 range. For example, the x is going from let's say the x is 0 to 90 degrees here, okay, and I want that 0 to 90 should be converted to 0 to 9000, for example, okay, or let's say 0 to 4095, sorry, 4095. What we will do is we'll say that x, which currently ranges from 0 to 90, should be changed to 0 to 4095, or let's say minus 4096 to 4095, and it will be converted and it will be obtained in the output as mapped, and the value mapped is what is the converted output of the map node. This is the beautiful node I was talking about. So now we'll proceed to the basic nodes that are there to control peripherals and the concept related to that. Thank you guys.